He's not here. Hello and welcome back to Calculus1. I forgot which one it was. This is the last section, 5.5 on You Substitution. So about half of your Calculus 2 grade depends on this. Hopefully you will learn this. Final exam will have at least 2 problems on at least 2, maybe 3. It's the same like the ones you see now, part A, B, A, B or ABC with the U sub. However, when you go to Calc 2, Calc 3, about 90 to 95% of your integrals are all U sub. So this is something that you absolutely must know if you are moving forward. Now, to immediately start, the U substitution is backwards chain rule. We know that antiderivatives, i.e. integrals, undo derivatives. So U substitution is going to be backwards chain rule. You also know that anytime you integrate, you can differentiate to check. I hope you did that for the problems on the exam earlier. So if you, let's say, had integral of, 6 over x dx to integrate, you say, okay, I kick out 6 and then I have 1 over x dx, and then that's 6 ln absolute x plus c. So if you have a problem like that, what?
Oh my god, I hate myself.
That was not a problem on the test. The test had a different problem.
No, I totally. That was on there. No, not even that. I didn't put the plus C. I'm so mad.
Oh, I'm gonna email you the meme.
I'm so mad right now. Okay, it's fine.
So,
Oh god. Okay.
so let's say you have a problem like this, then you can differentiate the answer, which is 6 ln absolute x plus c, to get 6 times 1 over x plus 0, which is 6 over x, which is where you started. So integration and differentiation go back and forth. Now, I already said that your integration is this U substitution part is going to be backwards chain rule. That means that if you had some kind of a chain rule problem, let's say you had sine x squared to deal with, well, the derivative of sine is cosine x squared and then times 2x, which gives you 2x cosine x squared. So this means that the integral of 2x cosine x squared dx is equal to sine x squared plus c. So now we would like to learn the method of U substitution so that we can use it in about 17,000 problems that are coming up in Calc 2 and Calc 3. Now, before we do the technique, let's say you have integral of 3x plus 5 squared dx. Now, something like this you already know how to integrate, because you can just square the content of parenthesis to get 9x squared plus 30x plus 25, close parenthesis, everything dx. And then you square each individual term. So you have 9x cubed over 3 plus 30x squared over 2 plus 25x plus c. And then you cancel what you can. Well, 9 divides by 3, nice, so that's 3x cubed plus 15x squared plus 25x plus c. And that will be the answer. Now if you want to, you can go differentiate and go back, factor it, and you will be able to compress it back into 3x plus 5. So not a big deal to solve this problem. Now if you take the integral of 3x plus 5, right, and raise it to the 83rd power dx, go ahead, FOIL, I'll wait. No, actually I won't wait. I'm just gonna leave forever. Foiling this, right? No. So what should we do? Well, let's test out the You Substitution method and learn the way it works. All of these problems, the way I look at it, come with a little bit of a, attitude to it. You put some attitude into it. You say, if this was just, x to 83, it would be so easy. But it's not, right? So you put that attitude there, and that's when you realize, well, how about if I just make the stuff I don't like go away by making a substitution? Because now, if I am to plug this in, I'd have this, right? Yay. Now, since you are replacing x with u in the expression right there, your dx needs to be replaced by du, which means that we have to find the connection between those two as well. So it's not enough just to retire what you don't like, right? You also have to balance everything and make sure that now all of your variables are u. You can't eliminate x out of height and not eliminate x out of width. Remember that the integral is the area of the rectangle, right? Where you have the function part to be the height and the dx to be the width, and then height times the width is the area of the rectangle. So you changed the height to be in terms of u. Well, you have to also change the width to be in terms of u. And you achieve that by simply differentiating this part. So du dx is equal to 3, from where du is 3 dx. Now, since you are replacing dx is du over 3. So, du over 3. Now, that 1/3 gets kicked in front of the integral, and the difficult integral now becomes a very simple integral. So now we have 1/3. Integral of u to the 83 is u to the 84 over 84. Plus c, exactly. Plus c. Now, 3 times 84, 342, right? That's what I said. So, u to the 84 divided by 352 plus c. 8 times 3 is 24. 3 times 80, 240 and 12. Yes, 240 and 12 is 252. Yep. Are we done? No. The problem was posed in x's and your answer is given in u's. That's like going to the store, you pay for your merchandise in dollars and they give you back the change in yen, right? So no. right? So we have to go back to the original variable, and that's variable x, right? So instead of u, we'll put 3x plus 5 in parentheses, and that's to the 84th, divided by 252, and then you have plus c. And now we're done. So we change the domain from x to u. We change the domain from x to u to solve the problem easy. And then we have to go back into the x domain to present the answer, because the problem was posed in x's. The answer needs to be also given in x variable. Now what you see here is the full problem from the start all the way through work, and then you can see also on the side substitution is done in blue. Now as you practice this, because right days till final, you have your substitution and you have dx. Generally students use these two, and I'll explain how you can use these two rather than switching this in. But generally when you go you immediately write the differential, because dx will go to the right side from the denominator anyway. So you just take the derivative of whatever is there and then put the dx on the side. If you have multiple terms, you have to put parentheses again. Good one. So now let's take a look at another example of this. Say you have the integral of x times the square root of 4x squared plus 9 dx. Now the previous one with the 83 power, you were able to cheat. Well, just lazy, but you were able to cheat because you could have, right, sat there a few hours and just, expanded everything. But in this case, you can't. You look at this and you say, well, there's nothing I can do. There's nothing to multiply, right? Nothing to combine. So if the U substitution doesn't work, then should be some advanced technique from Calculus 2, or I don't know, essential oils or whatever helps. I don't know. Today we have a different kind of environment. So what do? We start with u equals 4x squared plus 9, because that's what we don't like. We don't like that piece under the square root. Now we'll have a cool tool to actually show us what do we get to pick, but let's get there slowly. So now du is equal to 8x dx. So it's du over dx, but then you ship dx to the other side. So we have 8x dx. Now, do you have 8x dx? No, you only have x dx. You are missing an 8. So what you can do is you can fix it by placing an 8 and 1 over 8 outside, because they cancel to 1, right? So that's the trick that you can use only for constants. You can't fix the variable this way. Only constants. So if you need a constant which you don't have, you can just plug it in and then balance it out on the other side. So now you have 1 over 8 integral, and now in this orange peanut over here, you have your 8x dx. Do we all see that? Good. So what is the whole problem? It's square root of u du. Wow, this simplifies, right? if you consider it for a second. This is really powerful, right? So now 1 over 8, and we have integral of u to 1/2 du, which is 1 over 8. That's u to the 3/2 divided by 3/2 plus c. Now, we fix our double fraction here, so 8 cancels 2. And we just have, there will be a 4 there, so 4 times 3 is 12. So this works out to be u to the 3/2 over 12 plus c. Are we done? No. We have to go back to x domain. There is a sentence that you can ingrain in your brain, right? As you work this, you could say, I don't care about u, I care about the x. Because u variable is not the one you want, right? So I don't care about u, I care about the x. You say that, and it will click. So what is u? U is 4x squared plus 9 to the 3/2 divided by 12, and then we have plus c, and we are done. Now, before you say, well, we don't know if that's good or bad, well, let's try it. How about we check? All I need to do is to differentiate this monstrosity here. And if it works out, we're good to go. So to differentiate this, I will kick 1 over 12 outside as a constant, and then differentiate the parenthesis, which is 3/2 times the parenthesis to the 3/2 minus 1 is 1/2, times the derivative of the inside, which is 8x, and then plus 0, the derivative of plus c. So now I have 8 times 3 is 24 divided by 24, so they all cancel, right? 3 and 12 and 2 and 8, they all cancel, and we are left with x times the square root of 4x squared plus 9. Note that we had to do the chain rule to come up with the, right, to do the check, because U substitution is backwards chain rule. So of course you are going to use chain rule if you want to check. So our derivative matches the problem, therefore we're good to go. So I'm going to place 3 problems that include sine x. One of these 3 problems will not be possible to work out at all. Now, question is, can you spot which one? And you can simply say 1, 2, or 3, and then we can talk why. So the first problem is going to be sine cubed x cosine x dx. Problem number 2, integral of sine x cubed dx. And finally, integral of x squared sine x cubed dx. So one of these 3 problems, 1, 2, or 3, cannot be done at all with any of the techniques you learn in Calc 1, and it will be actually a pain in the neck to do in Calc 2. The other 2 are definitely U sub. So now let's see what do you think? And why? Yeah. Which one you cannot do at all? Well, we're going to go outside. You go with the middle. Great. So now we have three of you giving three different answers. One of you is correct. So which one? Top?
Does something have to do with the fact that the first one is sine cubed x, so that's like sine x cubed, but the second two are like sine x. Not that that means anything, but you see what
That
I mean?
actually means a lot.
Yeah, that's what I'm saying, but yeah.
It doesn't mean.
Well, I know it means something, but whatever.
It means everything. Where that cube is. All right. So which one is the not good one? Bottom one? Top one. And
The top one you could say that sine x is u and that's a u cubed.
beautiful.
But then
She just solved the top one. She said make a u to be sine x. So you get u cubed and your dx is cosine, so it's great. So first one definitely works. You can solve it just by looking at it.
But
Right?
then for
There's two
so
different
the last
axes.
one doesn't work because it's like it's the
What's
bottom
the
one,
big
right? Because
Alright, so well, see, it's a little bit. It's not fair of me asking this question now because I didn't give you the most important tool, right? And this tool has two different purposes here. Purpose number one is to actually help you solve every problem, and the purpose number two is to actually recognize that you can do you sub. So the tool which I did not give you, and it's very important to have it and remember it and memorize it, and I write it here in blood, is use function derivative pair method. This is developed by some ancient mathematician called Nick. Function derivative pair. Guys, the function part is going to be u and the derivative part is going to be du. You have to have them both. If you don't have the derivative present, well, you can't use u sub because you cannot replace dx. So the function part is going to be u and the derivative part is going to be du. So now that you have this piece of information, which of the three problems do not have a derivative present in any shape of a form, no matter what you pick for u? Obviously second or third, because we already know that the first one is good to go. First one is good to go because you see there is a sine and there is a cosine. Well, they're derivatives of one another. So if you pick sine to be a function, you have a cosine to be its derivative. Yes? Which one is bad?
I think it's the bottom. If you can do the bottom one, then I'm assuming you can do the top one. I mean, the bottom one looks more complex.
Doesn't matter.
there's the bottom.
If something looks complex, doesn't mean it's... I mean, your phone, your tablet is very complex.
What's your u?
the middle one you don't have enough to work with.
Exactly. The middle one has no derivatives anywhere.
See, I told you guys that.
You pick your sign. Where's your cosine? Nowhere.
Right
Guessed
from the
you were like,
beginning.
oh, it's gonna
I
be
said it's the middle one.
So, look at the middle one, guys. If you pick u to be sine, there's nowhere to see any cosines. And if you pick u to be x cubed, well, there's no x squared anywhere. Because the derivative of x cubed is 3x squared, right? So the first one and the last one, top and bottom, are the good ones. The one in the middle is the evil.
But did you know? Or were you...
That's okay. He used up his luck, so he will not be going
I
to.
used up my luck on exam too.
There you go. Ooh, the final is in 2 days. How fast? What's the cooldown on it? What's the cooldown time on it? If you put a Boom Katos passive, it reduces by 60 seconds. The cooldown on Earthquake and Wrath of the Berserkers. All right. So let's talk about the integral of sine cubed x cosine x dx. So we have this problem, and as I said, your goal is to look for function derivative pair. If you find a function, right, you want the more complicated stuff, obviously, so you can simplify it. So you make u to be sine x. The du is immediately cosine x dx. And then, when you do that, you have the integral of u cubed du. So the entire problem collapsed quickly onto u cubed du. And now, those of you that are struggling with trig a little bit or notation, whatever, sine cubed x is the same as sine x everything to the third power. So that's why sine x gets replaced completely by u and it's u cubed. So now when you integrate, you get u to the 4 over 4 plus c. And then I don't care about u, I care about the x, which means sine to the 4 x over 4 plus c. And we're done. The entire problem fits in 2 lines. Not a problem, right? The next one, all the way on the bottom, was x squared sine x cubed dx. And this is great to look at these 2 problems at the same time because they both have sine, they both have a cube, but the cube is at a different location. So now you have x cubed rather than sine cubed. And because you have x cubed, well, its derivative is 3x squared. And you go woohoo, because you do have x squared, right? So u is going to be x cubed. Du is 3x squared dx. We don't have a 3, right? So fix it.
On the outside.
Yes, add the 3 and add 1/3. This is why you should have 2 colors. If you don't have 2 colors, write the new line, because you will not know when you review your notes that 3 wasn't there to begin with, and 1/3 and stuff like that. So if you have 2 colors, like I do, well, I have 16 million colors, but you know, it's just because I'm better than you. If you have 3, if you have 2 colors, then just put the 3 in different color and 1/3. If you don't, just put a new line, adding a 1/3 and a 3. So now you have 1/3 integral. Here we go with the orange. So what we have there, right, in the peanut. I'm going to use the peanut because it's orange. If you're allergic to peanuts, please take 2 peanuts. That's going to be sine u du. Very good. Oh, wait, I forgot the peanut. There we go. Much better. So it becomes sine u du. And then the integral of sine is, very good, plus c. And then I don't care about u, I care about the x. Negative 1/3 cosine x cubed plus c.
I have a question.
Yes.
I don't. Why does the du go away at the very last step?
When you integrate,
Okay.
du is used up, right? When you integrate, so it's not,
Just
yeah. You had the integral of x squared dx is equal to x cubed over 3 plus c. So integral sign and dx are operators which tell you to change x squared into this. So it's like you can think of it as using them up to change function x squared into x cubed over 3. Those are operators, just like when you are differentiating, the differential operator goes away when you are done. So if you have derivative x squared is 2x. So this is like an instruction, right? This instruction says take derivative of what's in here, right? So that's what it means. It's like, instruction, license registration, it's instructions, so you know exactly what to do. You do anything else, no good, right? The integration is the same way. This pair is an instruction what to do with x squared. So, like, again, license and registration, which means integrate x squared to get, so they go away, right? Otherwise, you'd be stuck. If you put it back, you're stuck in infinite loop. License and registration, you give it, and it's license and registration. Well, you just gave it, you don't have one more, right? Good. All right, next problem. Let's see something. E to the 3x dx. You had to memorize this formula, so you should know the answer just by looking at this right now.
Onwards again.
Was it? Yes, e to the 3x over 3. I don't know if it was or not.
It was, I think.
It was? Oh, thank you.
It is.
There was yesterday when I...
That's what I said. Is that right?
Yeah.
3x over 3? Okay, Joe.
E to the 3x over 3 plus c.
Yeah, I'm so mad. Oh, that's it.
So let's do this problem. You already know what the answer is. Let's do the problem using U sub. So e to the 3x dx, we have that the u is equal to 3x because we like to integrate e to the x, right? So we're just going to make it e to the u. We don't like this business of having stuff there. So e to the 3x becomes now e to the u. Well, I'm not done because du is 3 dx. Now, do I have 3? I don't. So we have to put 3 in and 1/3 in front. So the problem now becomes 1/3 integral e to the u du. Here's the peanut for du, right? The 3 dx is the du peanut. That replaces, and then 3x changes with u, and the entire integral is in terms of u. What's the integral of e to the u? E to the u plus c. I don't care about u, I care about the x. And then plus c at the end. And you see that the formula which you had to memorize before, now you can actually do the long way. Let's take Yeah. Let's take a spicier problem. It's a little bit harder to see. Integral of tangent x dx. What is the integral of tangent? It's not going to be a basic integral. It's not on the list in 4.9 because the integral of tangent is not the basic integral. So now that you know that, there has to be some kind of trick with the U sub that would help us here. Yes? Excellent. We are going to write this as sine over cosine and then see what we can do from there. So sine x over cosine x dx. Oh, make sure you're writing this dx every time because it triggers my allergies. So now what?
You can split the integrals, right? Can't you make it integral sine x divided by integral cosine x? I've heard it before.
Nope.
No.
There is nothing like this. The integrals can only be split with plus and minus. That's it. If you remember that your product rule and quotient rule were special formulas for derivatives, you couldn't do separately anything. Same for integrals. You can only split over addition and subtraction. Multiplication and division you cannot split. So, what should we do? Well, remember what I said. Look for function derivative pair. Do we have function derivative pair? Yeah, we do, right? Can you give me an example of function derivative pair in this function and we'll try it? Derivative of sine x is cosine x. Now, since you said derivative of sine is cosine, then you are keeping cosine to be the derivative. So let's then go u equals sine x and du equals cosine x dx. Now, see how fast you hit the brick wall here. What do you have? You have cosine x times dx, and in a problem you have dx over cosine x. They are not the same thing. Right? Right. So when you have a fraction, it's tricky. When you have a fraction, most of the time, the function is the one in the denominator. Yes?
Sorry, keep going.
Okay, fine. This way. So, the function should be one in the denominator. And that way, we're going to avoid the issue. So, negative sine x dx for the du. So what happens now? Well, integral. Now you have your, well, we don't have a negative, right? So we have to place that negative and the negative in front of the integral so they cancel out. Now you have your peanut over here. So that's your du. And the whole problem becomes negative du over u. Now what's that? What's the integral of du over u?
Maybe 1 over.
Yeah, isn't the 1 over x is the derivative over the function, right?
So what's the integral of 1 over x or 1 over u?
Is it ln?
ln absolute x. So ln absolute u plus c.
I'll let you know because you're wondering. I had to put in L and X, I put in the absolute value.
Good.
So how can it be negative though?
The negatives on the outside like that.
All right, good. Now, the sentence, I don't care about u, I care about the x. So, negative ln of cosine x plus c.
Easy.
Well, there's one more thing we're going to do. Remember in calculus that tangent and cosine are not the pair, right? It's sine and cosine are a pair. What's tangent paired with?
Secant. Cosine. Let's keep guessing it. There's only 6, guys.
Yeah, it's one that starts with. So it's secant, right? So tangent secant is a pair. Now, is there a way for us to change that cosine into a secant somehow?
Yeah, 1 over cosine.
1 over cosine. So is there anything that can force that 1 over cosine in there? Yeah. Yeah, right here.
Or should we try finding it? But if we try it.
I already circled it. There's a negative 1 in front of ln. When it goes into as the exponent of the argument, it makes it into 1 over. So, ln absolute 1 over cosine x plus c, which is ln secant x plus c. And there it is. So what's the integral of tangent? It is ln secant x plus c. It's going to be on the menu for today, but you only have another 17 minutes.
Memes, it's okay.
12 actually.
We're able to divide by the -1 in there.
Not divide, you plug it in as the exponent. The negative 1 in front goes as the exponent of cosine. So it becomes 1 over cosine. All right, what else? What else do we have? We have, it's done. So now, because you can. Integral of something dx. I'll have to come up with what?
Dx over 1 plus e to the 2x.
You said e to the x.
Over 1 plus e to the 2x.
It's not that bad actually. Want to see something spicier? How about x cubed minus x squared plus 9? 6x squared minus 4x. Hopefully. It's a math problem. So let's see your math skills now. What are we looking for in each problem? Yes, function derivative pair. Great. Can you find one over here?
Then x cubed minus x squared?
Yeah.
Okay. Weirdly drawn 3. I think we're not supposed to Not supposed to find it.
So is it like 2u?
Oh.
2 it's 2 times the derivative of the bottom, right? No, that's wrong.
I said nice.
Oh,
And I was about to say something. You will have Make sure you bring your lab work today. Tomorrow.
Tomorrow?
Yeah, tomorrow we do more 5-5, final exam review, lab, and then Thursday is just final 5-7.
how many questions is the final?
12, 13, 15, 16. So we'll talk about that. The short answer. All right, so
Is it 2 absolute value u plus c?
yes, nice. 2ln absolute value x cubed minus x squared plus 9 closed absolute value plus c. It's obvious. Now, trust me, when you start working on partial fraction decomposition problems in Calc 2, problem like this is a step. You will be not writing anything on the side. You will immediately write the answer because you'll do so many of these by that time. You will be spotting ln's from a mile away. You'll be able to sense them before you see them, right? You will say like, I sense ln problem coming in, and then you would see a problem and say, yeah, I knew it, see?
Well, isn't it when you see division? You kind of know there's going to be an ln.
Pretty much when you see division, yeah, it's going to be probably ln. Well, you need the function on the bottom and the derivative on top. If you learned anything on the, in chapter 3, you learned that the derivative of ln of f of x was fx prime over f of x. Well, now you're going backwards. So if you have this, you will have ln of f of x. So, because they're backwards. So whatever formulas you memorized, they're always backwards formulas. So now, by kicking 2 in front, because you can factor 2, you're left with 3x squared minus 2x divided by x cubed minus x squared plus 9 dx. And now it's clear that the top is the derivative of the bottom. So u equals x cubed minus x squared plus 9. So whatever is the function is the u, and the du in parentheses 3x squared minus 2x dx.
Square root 2.
So now we have the integral, well, 2 in front, integral, and now you have du over u. So the top times dx is du, and the entire bottom is u, which is 2 ln absolute u plus c. And then again, I don't care about u, I care about the x, which means x cubed minus x squared plus 9 plus c. And then you can differentiate. This lecture is not done yet. We still have to talk about U substitution with definite integrals, which is going to be tomorrow. So definite integrals have limits. And when you change your integral, switch from x's to u's, the limits, which were x1 and x2, also have to switch to u. So we are going to work on that tomorrow. The last problem for today, before you leave, and I'm just going to demonstrate this problem, is subcategory, because you might run in a homework, you might run into this stuff as you practice. These are rare, but they pop up once in a blue moon, so it's good to see it at least once. It's called back substitution. So it popped up in a homework on Calc2 that was assigned by the department. Pretty much every student in class lost their minds. So let's just go through this. So let's say you have x square root of x minus 1, say, dx. Now, this is something that U substitution doesn't work for, right? You don't have x squared under the square root. You need x squared in order for this x to make sense, but you don't have it. So, you know when someone older gives you advice and you still just ignore it, right? And you just do it anyway, and then you get burned, right? Okay, good. Well, this is going to be one of those cases. You see it's not a U sub, you're going to ignore it, and you're actually going to profit. So, because there is a way to work it through. U equals x minus 1 because you don't like the fact that you have this mess under the root. So you're just going to do that. And then the du is clearly just 1 dx. You just put dx. So if you are to plug these back in, you don't have enough building blocks because there is nothing in for this x. Right? You have a square root of u du. But that x there is extra. And this is where the back substitution kicks in. You go to this one over here and you say x equals u plus 1. That's $1 million move right there. So now you have, instead of x, you have u plus 1, and then you have your square root of u, and you have a du. And now at this point in life, you can multiply, distribute root u, so that becomes u to the 3/2 plus u to the 1/2 du, and now you can integrate each one separately. U to the 5/2 over 5/2 plus u to the 3/2 over 3/2 plus c. When you're integrating polynomial like, right, with an exponent, you just add 1. So now, the double fraction, the 5/2 in the denominator becomes 2/5 when you put it up. And u was x minus 1. So, x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c. And then, if you are interested, go ahead, differentiate that. It will collapse into this if you want to check the answer. So this is the method of what we call back substitution, because we had to go back into our substitution piece and solve for extra variable that was floating around, which we couldn't sub for, that extra x. Now, all I need to do to fix this problem so it's not back substitution and you don't have to do this stuff is to just put a square there. Then it becomes the pure U sub problem, and you get to do that. So tomorrow we will do the part 2 for this. We will do more examples, obviously, at least 10 examples of U substitution. We will also go and talk about the important sections you guys absolutely must know in prep for Calc 2, otherwise you are doomed, and that word doom has 7 O's, not 2.
All right.
And lab time and final exam review time, so Thursday you guys can be done with the class. So see you all tomorrow. Ciao.